We are now going to graph r equals 3 plus 3 sine theta, and we're going to use symmetry to help us graph this equation. So there's three different types of symmetry that I'm testing for. There's symmetry with respect to the polar axis, there's symmetry with respect to the line of theta equals pi over 2, and there's symmetry with respect to the pole. And when I'm testing for symmetry, I have to test in three different ways, so I can't just do one thing and get an answer for all three. Here's my drawing that shows the three different types of symmetry that we might have. The first one we're going to test for is symmetry to the polar axis. The polar axis is what would be the positive x-axis in the rectangular coordinate system. The line theta equals pi over 2 is the same thing as the y-axis, and the pole is the origin. Testing for symmetry to the polar axis, we need to plug in negative theta and see if we get the original equation. Everything is testing to see if we get the original equation. And if we do, great. If we don't, it's inconclusive. It doesn't mean that you don't have that symmetry. It just means we're inconclusive. Taking r equals 3 plus 3 sine of negative theta. Remember that sine is an odd function, and so I can pull the negative from the theta and put it in front of the 3. So that means I have r equals 3 minus 3 sine theta. And unfortunately, that is not the same thing as the original equation, and so this is inconclusive. Testing for symmetry to the theta equals pi over 2 line, we're going to replace r theta with r pi minus theta. So we have r equals 3 plus 3 sine pi minus theta. We have cofunction identities, but we really haven't done anything where we know what the sine of pi minus theta is. I'm going to use the difference formula for sine to evaluate this. Recall that the sine of u minus v is equal to the sine of u cosine of v minus the cosine of u sine of v. That means we're going to have the sine of pi minus theta equal to the sine of pi cosine theta minus cosine pi sine theta. From the unit circle, we know that the sine of pi is 0 because y is 0 at pi. We also know that the cosine of pi is negative 1 because x is negative 1 at pi. When we simplify then, 0 times cosine is 0. A negative minus 1 becomes plus 1 times sine theta, which is just sine theta. I can then replace the sine of pi minus theta with sine of theta. So I have r equals 3 plus 3 sine of theta. And that is the original equation. So we have symmetry with respect to the theta equals pi over 2 line. The third thing we're testing for is symmetry with respect to the pole. In order to test symmetry with respect to the pole, we plug in negative r theta. So we have negative r equals 3 plus 3 sine theta. And I'm going to divide both sides by negative 1, which means that essentially each term on the right-hand side is divided by negative 1. Negative r divided by negative 1 is r. 3 divided by negative 1 is negative 3. 3 sine theta divided by negative 1 is negative 3 sine theta. And that is different, so this test is also inconclusive. We know that we have symmetry with respect to the theta equals pi over 2 line. This means that I can mirror things from one side to the other. So I can pick things in the first quadrant and mirror them to the second quadrant, and I can pick things in the fourth quadrant and mirror them to the third quadrant, or kind of vice versa. Using the values of sine of theta from the unit circle, at theta equals 0, the sine is 0. At theta equals pi over 6, the sine is 1/2. At theta equals pi over 4, the sine is root 2 over 2. And at theta equals pi over 3, sine is root 3 over 2. At theta equals pi over 2, sine is 1. Recall the equation is 3 plus 3 sine of theta. taking those values from the unit circle, I do 3 plus 3 times 0, and I get 3. 3 plus 3 times 1/2 is 4.5. 3 plus 3 times root 2 over 2 is 5.1. 3 plus 3 times the square root of 3 over 2 is 5.6. And 3 plus 3 times 1 is 6. And I'm rounding these to the nearest tenth because it's hard to get even more accurate when you're graphing by hand like this. Let's plot these points. At theta equals 0, I'm going to go out to the third circle because r is 3. And I'm also going to mirror that on the other side of the graph at pi, 3 out. It's as if you're folding the paper at that dotted gold line and you're putting the dot exactly in the same place on the other side. At pi over 6, I'm at 4.5, so I'm going to be between the fourth and the fifth circle. And I'm also going to mirror that at 5 pi over 6 because I have symmetry with respect to the theta equals pi over 2 line. At pi over 4, I'm at 5.1, so I'm just a little outside of 5. I'm going to mirror that at 3 pi over 4 as well. At pi over 3, I'm at 5.6. I'm a little bit larger than 5.5. I'm going to mirror that at 2 pi over 3 as well. And then at pi over 2, I'm at 6. We're getting a little bit of an image that looks like a circle, but we don't really know what's happening in the third and fourth quadrant. So let's pick some values, 7 pi over 6 and 5 pi over 4 to see what's happening. From the unit circle, the sign at 7 pi over 6 is negative 1/2. The sign at 5 pi over 4 is negative root 2 over 2. The sign at 4 pi over 3 is negative root 3 over 2. And the sign at 3 pi over 2 is negative 1. 3 plus 3 times negative 1/2 is 3 minus 3 over 2, which is 1.5. 3 plus 3 times negative root 2 over 2 is 0.9. 3 plus 3 times negative root 3 over 2 is 0.4. And 3 plus 3 times negative 1 is 3 minus 3, which is 0. So let's plot these points and use symmetry as well. At 7 pi over 6, we're at 1.5, just in between circles 1 and 2. I'm going to mirror that at 11 pi over 6 as well. At 5 pi over 4, we're at 0.9, so just shy of the one circle. I'm going to mirror that at 7 pi over 4 as well. At 4 pi over 3, we're at 0.4, so in between the origin and the circle 1, which I'm going to mirror at 5 pi over 3. And then at 3 pi over 2, we're at the origin. This is a limacon, and it's a cardioid limacon because A and B are equal to each other. I'm going to connect this shape then. And this is the graph of the cardioid limacon. We're going to graph r equals 1 plus 4 cosine theta, which if I look at my chart of the different types of graphs that we have in polar coordinates, I know that this is a limacon. And in this case, the A value is less than the B value. So I believe it should have a loop. The orientation and the symmetry depends on the function that we have. So we have cosine here. Let's determine what the symmetry is. So let's start out with our 3 different tests for symmetry. If I substitute in negative theta, I get r equals 1 plus 4 times the cosine of negative theta. And cosine is even. And so the cosine of the negative angle is the same thing as cosine of the angle. That's r equals 1 plus 4 cosine of theta. This means that we do have symmetry with respect to the polar axis. And that is the positive x-axis. To test symmetry of the line theta equals pi over 2, we're going to plug in pi minus theta. So we have r equals 1 plus 4 cosine pi minus theta. And in the previous problem, we used this difference formula for sine, but now we need to use the difference formula for cosine to determine what the cosine of pi minus theta is. Cosine of pi minus theta is equal to cosine pi, cosine theta, plus sine pi, sine theta. And really, we don't know what the cosine of theta is or the sine of theta. We're just evaluating the pi portion because we can use the unit circle for those values. Then the cosine of pi minus theta is equal to the cosine at pi is the x value at theta equals pi, and that's -1. So I have -1 times the cosine of theta plus the sine at pi is the y value at theta equals pi, which is 0. So then I have 0 times the sine of theta, which means that the cosine of pi minus theta is equal to negative cosine theta because 0 times sine is 0. My equation then becomes r equals 1 plus 4 times negative cosine theta, or r equals 1 minus 4 cosine theta, which is different than the original equation. That's not going to work, so this is inconclusive. Last symmetry we're testing for the pole, which is the origin. We're going to substitute in a negative r. We have negative r equals 1 plus 4 cosine theta. Dividing everything by a -1, we get r equals 1 divided by -1 is -1. 4 cosine theta divided by -1 is -4 cosine theta. And that's different than the original equation, so this is also inconclusive. The equation we're given is r equals 1 plus 4 cosine theta. And we know that there is symmetry with respect to the polar axis. And the polar axis is the positive x-axis. What I'm going to do then is I'm going to pick points that are in the first quadrant so that I can mirror them into the fourth quadrant, and then figure out if I need to evaluate anything going on in the second and third quadrant. Using the unit circle to evaluate cosine first so I can then figure out what r is. The cosine at 0 is 1. It's the x value. The cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. The cosine of pi over 2 is 0. And then I'm going to take 1 plus 4 times that value to get my r approximation. 1 plus 4 times 1 is 5. 1 plus 4 times root 3 over 2 is approximately 4.5. 1 plus 4 times root 2 over 2 is approximately 3.8. 1 plus 4 times 1/2 is 3. And 1 plus 4 times 0 is 1. Let's plot these points and then go from there, see if we need to do more points. At theta equals 0, we have a distance of 5, so go to the fifth circle and make a dot. At theta equals pi over 6, I'm at about 4.5, so I'm in between the fourth and the fifth circle. At theta equals pi over 4, I'm at 3.8, so almost just a little further than halfway of the third circle. At theta equals pi over 3, we're at 3. And at theta equals pi over 2, we're at 1. Now I can mirror that using the polar axis. So at theta equals pi over 2, I was at 1, so now I'm going to drop down opposite that. At theta equals pi over 3, I was at 3, so I'm going to go to 5 pi over 3 and do 3. At pi over 4, I was at 3.8, so I'm going to go to 7 pi over 4 and do 3.8 as well. At pi over 6, I was 4.5, so I'm going to do at 11 pi over 6, I'm also going to do 4.5. It looks kind of like a circle, but I know now that I've been through the entire section that this is a limacon and that the A value is less than the B value. So there's actually a loop, but the loop is still in the first and the fourth quadrants. So how do I get those smaller values? What I'm going to do is I'm going to pick some angles that are in the second quadrant and see what happens, because I believe I'm going to get some negative R values, which means I then graph the R, but I use theta plus pi and I get it in the opposite direction. So let's pick some second quadrant values. Using the unit circle, the cosine at 2 pi over 3 is negative 1/2. The cosine of 3 pi over 4 is negative root 2 over 2. The cosine of 5 pi over 6 is negative root 3 over 2, and the cosine at pi is negative 1. Then I'm going to take 1 plus 4 times that value to get my R approximation. 1 plus 4 times negative 1/2 is negative 1. 1 plus 4 times negative root 2 over 2 is about negative 1.8. 1 plus 4 times negative root 3 over 2 is negative 2.5 roughly. And 1 plus 4 times negative 1 is negative 3. I then need to turn these points into points that are R theta plus pi. So let's convert these points. Recall that a negative R theta is the same thing as R theta plus pi. I'm going to make each of the R's in these ordered pairs positive, but then I'm going to add pi to each of the thetas to get the coordinate. So 2 pi over 3 plus pi, or 3 pi over 3, so that they have the same denominators, is the point 1, 5 pi over 3. 3 pi over 4 plus 4 pi over 4, which is just 1 whole pi, is 1.8, 7 pi over 4. 2.5, 5 pi over 6 plus 6 pi over 6, running out of room there. I have 2.5, 11 pi over 6. Pi plus pi is 2 pi, so I have the point 3, 2 pi. And now I can plot these points, and notice that their values are different than the other values that we had. They're smaller, and so this is where the loop comes in. Well, at 5 pi over 3, I have a point of 1, and I'm going to draw these in yellow just so you see that they're the second points that we did. So 5 pi over 3 has a circle distance of 1, which I can mirror over the polar axis on the pi over 3 theta angle. 7 pi over 4 has a distance of 1.8, which I can mirror at pi over 4. 11 pi over 6 has a distance of 2.5 roughly, which I can mirror at pi over 6. And then 2 pi, which is also 0, has a distance of 3. So let's connect this graph. And here is the graph of 1 plus 4 cosine theta, which is a limacon with a loop.